isotopes and average atomic mass, so chemical quantities. So carbon 12, we're looking at regular carbon, right? Because the atomic mass of carbon is 12, right? What we look at is, what does it mean? Well, the mass of one atom of carbon, okay, is 12U. Right? Remember, U represent the units. So another way to look at this is as follows. That 1U represents 1/12 of the mass of one atom of carbon. So if one carbon atom is worth 12, is representing of 12 atomic units, okay, that one atomic unit represents 1/12 of that. Okay. Now, the masses of all other atoms are defined by the relationship to carbon 12. So carbon 12 is what they base it on. So let's look at oxygen 16. If we look at our periodic table, we'll see that oxygen has an atomic mass of 16. But let's prove it. We find out that that oxygen has a mass that is 133% of the mass of carbon. Okay? Don't worry about how we got this right now. We'll worry about it later on. But this is here a given. So we've given to you that the fact that oxygen is 133% of the mass. So what we do is, whenever we have a percent, we always want to change our percent into a decimal. Right? So how do you change 133% into a decimal? It's one, but how did you get that?
Move decimal place.
You can move the decimal place or just divide your number by 100. So anytime you get a percent, you're always dividing that number by 100. Okay? And that will allow us to remove the percent sign and convert it to, as it was stated, 1.33. So we get 1.33, 12.000U. What's that the atomic mass of? Carbon. But we said that 133% of the mass of oxygen is represented by carbon. So we divided these two, multiplied it by 12.000U, and we get 16.0, which represents the atomic mass of oxygen. Okay? So we're going to be doing calculations like this. So what we have is, we have the percentage of oxygen that is related to carbon's atomic mass, and we found out what the atomic mass actually was. Okay. So, now, isotopic abundances. All atoms in a given element do not have the same number of neutrons. They do not have the same mass. They are all composed of varying masses because they include their isotopes. As we said, okay, so if we have here as this example, magnesium having 3 naturally occurring isotopes. What we have here at the bottom, we have a diagram of the magnesium supplement that you can buy at a grocery store, a health food store. Okay. That magnesium is not just the magnesium that we know of, okay, having the 24U, the atomic mass of just 24. It consists of all 3 of the isotopes, okay, in varying percentages. Okay, so if we look at the magnesium, okay, in that container, technically 79% of the magnesium in that container, in each one of the pills, consists of your normal magnesium that you'll find in the periodic table. Okay, 10% of it is made up of the isotope, one of the isotopes of magnesium, and 11% is made up of the 26 atomic unit mass for magnesium. So notice here the 2 different isotopes still found within that supplement, magnesium supplement. So anytime you see your formula, so we look at magnesium here, whether it's in the supplement or here if we're looking at salt water, which is MgOH2, so magnesium hydroxide. That magnesium is made up of these 3 isotopes, okay, but in the same exact percentage. 79%, 10%, 11% of that. You're not going to have to worry about memorizing these numbers, okay? We're going to have calculations that we're going to need to do. You will be given these numbers, okay? Or you'll be asked to find them using the calculations, but we'll go through a couple of examples, okay? So as we said, regardless of whether it's the magnesium found in one of those two, it is always made up of those three isotopes in this same proportion. 79% of it is of the regular magnesium, 10% of one of the isotopes, 11% of the other. Okay. So the relative amount in which each isotope is present in an element is called the isotopic abundance. It can be expressed as a percent or as a decimal. Okay? Usually if you get the percent, right? Something says, let's say 79%, as we said. Remember, to get rid of the percent, always get rid of the percent by dividing it by 100. Okay, so whenever you get your percent, always divide it by 100, remove your percent sign, and get it into a decimal, because that's how you do your calculations. You turn it into a decimal first before you make any of the calculations. So, when chemists consider the mass of a sample containing billions of atoms, they must take the isotopic abundance into account. Okay, so average atomic mass. The average atomic mass of an element is the average of the masses of all the element's isotopes. So as we said, the magnesium, right, that we found in the supplement or in salt water is within that same proportion. Okay, so that number that we get here, so for this example of carbon here we have 12.01 for the atomic mass, but this is an average atomic mass. Okay, so 6, this is not the chemical notation, this is the way it would appear in your periodic table, with the atomic number up at the top corner, the atomic mass at the bottom. Okay, so what we have here, that the atomic mass that can be found in your periodic table represents the average mass of all the naturally occurring isotopes of the elements. So what we're looking at is we're taking into consideration all these isotopic abundances. The fact that it's not just the 12U of carbon, but it could be the 13, it could be the 14. So which means that we're looking at the atoms of carbon that consists of more neutrons than some of the others. Okay? So, carbon isotopes. Carbon is made up of several isotopes and not just the carbon-12. Okay, that's the one that we know of in terms of our periodic table. Carbon is made up of 3 known naturally occurring isotopes, which we talked about last class. If all these isotopes appear in equal amounts, why is the atomic average, the average atomic mass 12.01? Okay, because if we look at the different carbons, we have carbon that has 12U. We have the carbon-13, and we have the carbon-14. If you were to find the average of all these, right, what would be the average of all 3 of these atomic masses? 13, right? 13. But look at what the actual average atomic mass is, which means carbon-12, right, makes up pretty much the majority of all the carbons that are found in any type of compound. That the isotope is rarely found in the different types of compounds. So if we looked at something like carbon dioxide, 98.9% of the carbons in this formula is made up of the carbon-12. Okay? The carbon-13, 1.1% of it. So 1.1% of the carbons found in all the molecules of carbon dioxide is only going to be 1.1% of the isotope carbon-13, which will have the extra neutron. Okay? And then we have carbon-14. Okay? Carbon-14. Look at how small this percentage is. 1 times 10 to the power of -10%. So think of all those zeros. That's how small of a percentage of those isotopes are found in that carbon molecule. Okay? So remember that anytime you see a formula, that formula is made up of the different isotopes. Okay, in carbon, it's regular carbon, the carbon-12 is made up of the majority of all the carbon molecules.